Hey guys, Zong here, back with another math video. In 2 days, AMC10A will begin, and to help prepare you for that, I decided to do a special sort of video. I haven't done this problem, I haven't looked at the solution, I haven't seen it before, because I don't usually do AMC practice problems, or any practice problems at all. Maybe that's why I suck. Anyway, so I'm just going to show you my thinking process for going through this problem, and hopefully you can get something from that. And I'm sort of okay at geometry, so hopefully I'll be able to solve this, I hope. Without further ado, let's get started. So, I'll just read it. Circles centered at A and B each have radius 2 as shown. Okay, radius 2. So this and this, those look like lines that are radii. So I'll write down what I know. As I go through the problem, I write down what I know. Usually I would actually just mark directly on the diagram because I'm a messy person. But I think the diagram is too small in this case, and my brush is really big. Okay, point O is the midpoint of AB. OA is 2 root 2. It's 2 root 2. Segments OC and OD are tangent to the circle center at A and B respectively. Okay, OC and OD are tangents. What does that mean? Well, it means that if they're tangents, it means that the tangent lines that are tangent to the circle are always touch the circle at a 90-degree angle to the center of the circle. So that means angle ACO equals 90 degrees. Because tangent lines always touch at a 90-degree angle to the point to the line that the point in the center of the circle form. So always perpendicular to the line that is directed to the center of the circle. I don't know how to say that, but you can just look in the diagram. I'll add some right angles, and yeah, those are 90 degrees. Yeah. Okay, that might be useful. EF is a common tangent. Okay, same thing. So these are right angles, and that means that EF is like EF is parallel to AB because there are two 90-degree angles, and of course this sort of looks like a rectangle, and because common sense. So this is EABF is like a rectangle, and EF should be parallel to AB. Okay, so I know that. What is the area of the shaded region ECODF? Okay, that's interesting. Usually if I have a weirdly shaped shaded region that involves circles, I know I'll eventually have to subtract the area of some sector of the circle, or subtract the area of the circle in some way to get the answer. How should we split this shaded region up? Well, maybe we can make some calculations first. So OA is 2 root 2, so this is 2 root 2. And since this is symmetrical, I'll apply all my math to the right side too. EA is 2, and since the radius is 2, AC is 2 as well. And since this is a right angle, 2 and 2 root 2, so this should be 2 as well. Since if you have a right angle and this is 2 and this is 2 root 2, this should also be 2. And then that means this is 45 degrees because the legs are equal. Okay. So that means AOC is 45 degrees. Similarly, okay, then we can find the angle COD. Because if AOC is 45 degrees, this angle right here, because it's 2, 2, 2 root 2 in the 90 triangle, that means that angle BOD is also 45 degrees. And since that means that, therefore, angle COD equals 90 degrees. Because this angle plus this angle must equal 180, and so 180 minus 45 equals 90 degrees. So this is at a right angle. Okay, well that's actually good because that's part of the shaded region, right? Maybe I'll take this triangle out here because that seems like a pretty normal triangle. Okay, so if this is 2, if AC is 2 and CO is 2, that means CO is 2. That means DO is also 2. And since this is 90 degrees, COD is 90 degrees. This is this top leg, CD. I can't write it up there because there's no room. CD equals 2 root 2. Because CO is 2, DO is 2, and this is a right angle. And of course, with two legs of 2 and like the right triangle, that means the hypotenuse is 2 root 2. You can just use a squared plus b squared with c squared for that. Okay. What's the area of that triangle? So area of COD equals, since it's just a right triangle, it's just leg base times height divided by 2. So it's just 2 times 2 divided by 2, which is 2. That's easy enough. So we found a portion of the shaded region. How do we get the rest of it? That's a weird curve. I'm thinking I should extend. I'm thinking I can either draw a straight line down like this, down to C, and then find the area of this, and then subtract the area of the sector. But I feel like that's sort of like annoying, like because like I don't want to find the area of this trapezoid, and maybe I can just draw a triangle. Maybe I can just extend AC and extend BD. So I have like a regular triangle here, which then I can subtract from. Okay, that seems easier. So that's what I'm gonna go with. So this is a right angle. This is 2. Let's see what I can do here. If that's 2, okay, good. Because if OAC is 45 degrees, if AOC is 45 degrees, that means this point you have GH. I'll call it GH. If AOC is 45 degrees and EAO is a right angle, because this is sort of looks like a rectangle, right? So EAO should be a right angle because of course this tangent is connecting both circles and that's perpendicular and proper and so common sense, this should be a rectangle. So this is a right angle. So and since AOC is 45 degrees, that means EAG also equals 45 degrees because these two angles must add up to 90 degrees. So if EAG is 45 degrees, EA is 2, and AEG, this angle is 90 degrees, that means EG is 2 as well because 90 degree and there's 45 degrees and thus, and there's one leg that's 2, the other one must also be 2 because 45, 45, 90 triangles. Similarly, we do the same for the other side and we have 2 triangles that are like that. Okay, so let's find the area of this sliver. So these slivers right here. What's the area of that? That would probably be, I'll draw a diagram like this. That'd probably be the 2 times 2 over 2 minus sector of circle. That minus that. This is what we're trying to find. So what's the area of this? Okay, well, let's think about that for a second. If the sector, if this angle, if EAG is, well, that's also EAC. If EAC is 45 degrees, then since 45 degrees is 1/8 of 360 degrees, that means that this sector of the circle should be 1/8 of the entire circle. And what is the entire circle? The entire circle is just 2 times 2 times pi, which is pi squared, equals 4 pi. And this small sector, since it's 45 degrees, you have to divide 45 degrees by 360 degrees. It's intuitive because, number of degrees and etc. Basic geometry equals 1/8. 1/8 times 4 pi equals pi over 2. So the area of this sector is pi over 2. The area of the entire, so to get the sliver, we need the area of the entire triangle, which is 2 times 2 over 2, base times height. Subtract the area of this arc, or sector, or whatever you want to call it, minus pi over 2, and you get 2 minus pi over 2. So that's the area of these small slivers right here. Okay, so just gonna make some room. Okay, last things last, we have to find the area of this trapezoid. So currently we have 2 minus pi over 2. There's 2 of them, so we multiply them by 2. And then there's this triangle right here, and that's just 2. Okay, that's what we have so far. Now for that trapezoid. Trapezoid is just base times height. So I'll draw it out right here. It's just, this will be A, B, those are variables. This will be height. So what's A? Well, we know that OA is 2 root 2, right? Now we know that this is sort of a rectangle just by looking at it. And we know that OB is also 2 root 2, so EF should be 2 root 2 plus 2 root 2. That's 4 root 2. And EG and FH are both 2. So GH equals 4 root 2 minus 4. So A equals 4 root 2 minus 4. So what's B? B, as we established before, is just CD, right? And CD we already have here, it's 2 root 2. So B equals 2 root 2. Now what's height? FB is 2, right? So what's the height of this right here? What is this height right here? Let's think about this. To find the height of this small sector, I don't know what to call that line. Well, ABC, if GHI, we'll call it I. DI, what's DI? Well, if this radius is 2, so DB is 2, this is 90 degrees because we drew a perpendicular line directly downward into OB. And if we know that OBD is 45 degrees, then the triangle sort of looks like this. 2, 45, and that right angle. And this is H. I mean not H, this is DI. DI would equal 2 over root 2, which is just 2 square root 2 over 2, which is 2 root 2. Okay. So DI is root 2. So the height would just be this height, this sliver right here, it sort of looks like this, FB DI, and then it sort of looks like the trapezoid is over here, right? The height would just be FB minus DI. Since we know FB is 2, H equals 2 minus root 2. And the area of a trapezoid is just A plus B times height divided by 2. Times height divided by 2, which is just, what was, so 4 square root 2 minus 4 plus 2 square root 2 times, let's see, so H was 2 minus square root 2 over 2, which should be just, let's see, 6 square root 2 minus 4, 2 minus square root 2. Let me just do these calculations in my head. Over 2. That's, I'm running out of room. So that's, let's see, so that's minus 4, so it's plus 4 root 2 plus 16 root 2. So minus 12 minus 8 minus 20 over 2 equals 8 root 2 minus 10. So that's the area of the trapezoid. So then we have, then we add that to the total area. Plus 8 square root 2 minus 10. And then you get 4 minus pi plus 2 plus 8 square root 2 minus 10. Which is, so that would be 8 square root 2 minus pi minus 4. Yep. And that is the answer. And let's see which one of these is, I hope I got it right. It'd be funny if I didn't get it right. I think it's B. Yeah. So, yeah, that's how I did it. A lot of bashing. I don't think the problem is that big of a deal. Just a lot of bashing, triangle bashing, etc. Nothing really special, no trigonometry, nothing special like that. So if I can do it, you can do it. I'm really stupid, okay? So you can do it. If I can do it, you can do it. Good luck on the AMC, and I'll see you next week. Or 2 weeks. Points along this line, etc. And what's interesting is that if you move this point to the right, and one ray from quadrant 2 moves to quadrant 4, and you also move it 1 point up, well, that means one ray from quadrant 1 goes to quadrant 3. And because you can do these simultaneously and still have the same